Hello and welcome to the Quarkus Deep Dive. I'm Ioannis and this is George. This is the fourth session on Quarkus today, so we wanted to make it a little bit fun, but also deep in the sense that we will try to demonstrate more advanced features of Quarkus. So it's going to be a full-on live coding with no slides, just coding. And would you like to say a few things about what we are going to demonstrate today?
Sure. First, I'm going to congratulate everybody for sticking with us. I mean, I know it's not been easy all these hours, but it means a lot to us. Thanks a lot. So the idea here is that we want to showcase a few, let's say, more advanced features like reactive streams, gRPC,
Corpus
Cli,
UI in Quarkus, Web UI in Quarkus.
And a very slight way of creating extensions, how you can create your own dev service, right? So I'll just show you initially what we're trying to build, and then we'll get on to like how we're going to do it. So this is a Google Maps API where we're in a starting location where we have a vehicle. By looking at the shape and reading where we are, can anybody guess where this is? And also taking into account that this is vehicle, right? Any idea where this is? It's a very famous motorsport
San Giorgio
temple.
It must be in Italy.
Yeah. Okay, so it's Monza, Italy, the track of the probably most famous F1 track. So what we want to do is basically we want to first of all show you how very simply we can with reactive streams make like a UI where the position of a vehicle is continuously updated on a map. So that's the very first thing we do. And then we want to show you how Quarkus, if you have really advanced needs in your company and you want to create developer tools, right, for other developers to easily consume, we'll want to show you how you can create an extension that will allow you to, let's say, embed a client that obtains GPS position information from any application, right? Yeah, so we have a question.
Is there any performance difference between reactive streams and JAX-RS reactive resource?
So we are going to use JAX-RS to return a reactive stream publisher, which we call a multi, right? So we're going to be using both things. So technically, this is the JAX-RS endpoint is going to be returning a server-sent events. So on the wire, basically, it's server-sent events, right? So we're using both. It's not either or. We're using both things, right? So JAX-RS to expose it, and reactive streams multi in this case to actually encapsulate the logic of the stream of position data.
So to summarize what we are going to show today, we are going to show a React app that it is embedded inside a Quarkus application that tracks the position of the vehicle real time by consuming an external gRPC service. The way that we will consume the gRPC service is by implementing our own Quarkus extension for consuming that service. And we are also going to demonstrate how you can implement a dev service for that Quarkus extension. So, first thing first is to create the actual skeleton of the project. We are going to use a Quarkus extension that's named Quarkus Quinoa. And what that extension does is that it populates a web UI folder inside your Quarkus application where you're able to add any kind of JavaScript-based project, and Quarkus will manage that for you. What that means is that when you start your Quarkus application, it will also start a Node.js server for serving the React app, and it will also employ and make use of the Quarkus facilitates both for the backend and the front end. What this means is that things that we've been seeing today, like dev mode and stuff like that, will be available both for the front end and the back end. That is extremely useful because you don't have to manage two runtimes, one for the Quarkus backend and one for the React. You get one, and you get all the dev experience goodies that we offer for both.
Right. I've already gone ahead and executed this Quarkus create app command, and so we're adding, as Jan said, the Quinoa extension, and we're adding Resti's reactive. And basically, I haven't done it, I didn't show it here, but this web UI was automatically populated. All we did, we copied in a few JavaScript libraries to show the map, right?
Yeah, exactly.
So the first order of business is to get this to move, right? So let's do the absolute simplest thing and hard code some position data.
Yeah, the simplest way to do so is to add a method to our generated resource that will return the coordinates in as server-sent events.
Excellent. So yeah, let's.
So the path that we are going to use is the GPS, and the exact method that we'll use for returning those coordinates is going to use the path track.
Yeah. So we create this JAX-RS resource under /GPS/track. It returns this multi. So you want to explain what this multi thing is?
So Quarkus uses Mutiny for doing the reactive stuff, and Mutiny has two main constructs: the uni and the multi. The uni is when you want to do reactive things that return a single value back, and the multi is when you want multiple values, as the name strangely enough implies.
Sorry. So yeah, basically you return a stream of values which could potentially be endless, right? In order to get the boilerplate out of the way, we're telling it that we're producing server-sent events, media type, and the subtype of the type of the server-sent event is text plain. So all we're going to be doing is returning in each line, basically, it's
a string that contains the latitude and the longitude, which are needed to pinpoint the vehicle on the map.
Excellent. So first thing we need to do is we need to get some coordinates, but I'm not going to search for them. I already have them in memory. So basically what I'm going to do here is I'm going to create a hard-coded list of these values.
And now we are seeing George doing multiple carousel semantics.
I just love IntelliJ. I'm sure you have a better way to do this in Emacs. So we're just going to get this string out of the way. A list of strings. Okay. So we want, basically this is going to contain the entire length of the track, right? Private.
So the idea is that we declare a list that contains all those coordinates, and through muting in multi, we are going to fire every 1 second, and for each second, we are going to grab a value from that list and return it as a server-sent event.
Exactly. So
we have muting. Multi create from.
So we're creating, we want to create this multi, but as Jan said, this is an endless stream, and we want to continue looping over the same, like when we reach the final coordinate, it's like it's a track, right? So the car keeps on going from the start. So we're going to say tick. So here we're witnessing basically the Quarkus is a reactive stream implementation, the API in action, right? How I would say how user-friendly it is compared to the other solutions out there, where you like have under one method, you have like under one class, you have like 500 methods. It's impossible to figure out. So here you have things grouped, right? So create from and ticks will allow us to send an event every 1 second, as Jan said, of seconds, 1. And now what we're going to do is every second we're going to
Map
take
it
that,
so that we grab a value from.
right, and coordinates get, and now what we want to do here is that, we need to,
You need an index.
yeah, we need an index, atomic integer, I is new, atomic integer. We start from 0, and I mod the coordinate length size.
We are using the
Oh,
mode
sorry.
here so that when we exceed the size of the list, we return back to 0, and this way is how we implement the loops.
Excellent. So now I think that we're done for this extremely simple use case. So again, all we want to do is illegal start of. Okay,
You have a
yes,
comma in the end of coordinates.
of course. So what we want to do is let's hopefully make sure that our map coordinates are being updated. So if I refresh here, we're seeing the vehicle go around the track. So every second gets a new coordinate, moves around, and that's the very simple use case, right? So everything's hard coded. The only sophisticated thing here is the use of mutiny and server sent events, right? Nothing really revolutionary here. So you want to describe what the next step
Yeah,
is?
so the next step is to consume a service. I have already created behind the scenes a service that generates those coordinates and returns that. We have a Docker container providing those that service. So we need to create an extension that will consume that service. This service is powered by gRPC, and gRPC is an RPC framework which uses protocol buffers for defining the contract of the communication. So I think that the first thing that we better show is how the Proto File looks like.
Yeah, so, sorry, just before we do that, I just wanted to show what we're trying to change. Remember here, we have the same JAX-RS resource, and what we're changing here is that instead of returning hard-coded values, we're getting them from a...
From a client instance, yeah.
Exactly, from a client instance. So this is our final code, right? And like you said, we're going to use gRPC. Okay, so how many of you here have used gRPC before? Okay, how many have like a vague understanding of what gRPC does? Okay, right. So you want to explain a little what this Proto File is and the whole logic behind gRPC?
So the Proto File allows us to specify two things. One is the format of our messages that our services are going to exchange. So in this case, we need to define a single message for specifying the position, which contains two double fields, the latitude and the longitude. And the other is that we need to specify the actual RPC that we are going to implement. In our particular case, we just need of a method that we, let's say, track, that accepts no arguments, so it gets the empty thing. This is a protobuf arguments, but in protobuf you can't define RPC methods with actual no arguments, so you need to specify the empty one. And that method will return a string of positions, which is the method just defined.
So if we wanted to look at the code, basically then what we're trying to do is this track method here is the actual implementation of what were defined earlier.
Yeah, exactly. So Quarkus provides an excellent extension for supporting gRPC. It's called Quarkus gRPC, strangely enough. And this extension allows you to automatically generate Java code, both for client stats and servers, from protocol buffer files like the one that we are seeing here. Just by running the actual build, the extension will detect the presence of the file and will perform all the code generation required. Now, for the people that have used gRPC and protocol buffers in the past, most probably you already know that you can use the Proto command in order to generate all the actual code needed. What Quarkus gRPC does on top of that is that it also generates implementations that are based on Mutiny. Mutiny is the reactive framework that we mentioned earlier, and it's a huge step forward compared to the Stream Observer API, which comes out of the box when you do gRPC generation. So it's much more friendly and much easier to consume and use, especially when it comes to cases like server streaming, which is what we are going to demonstrate here. Now, when we add the Quarkus gRPC to our project and perform the actual build, one of the generated code is the Mutiny gRPC GPS service gRPC, which is what we are going to use in this actual project. So, would you like to show how we are going to consume the generated code?
Yeah, so like you said, the idea is that our tracker client, right, should return a GPS method which returns the type we want. And then that type has the track method, which is empty, and this is the one that returns the stream of position, just like we defined it in our proto file, right? So remember, our proto file was, well, our proto file, remember, is the contract. So the contract said that the track method takes empty input, returns a stream of position. And the implementation that Corpus generates looks like this, right? You return a multi of position, right? So as Ioannis said, this is generated, this is out of the box, right? You just add Quarkus gRPC, you build the application, you build the module, and this is generated for you. But
in theory, we would just add this to our project and consume the gRPC service without any further fuss. However, in this particular demonstration, we want to wrap the generated client in an extension. Any idea why we want to do that? Well, the main reason in our case is that we want to also implement a dev service. Why do we want to implement a dev service? Because we want, when we try and develop our actual application, to have the service that provides the coordinates for us automatically start in a Docker container without having us worry about how we are going to start the service, where the service runs, what's the URL, do we need to configure credentials or stuff like that. So for all those reasons, we prefer to wrap the actual client in an extension, implement the dev service, and this is what we're going to show you next.
so the Quarkus CLI, figure this out. The Quarkus CLI, as we mentioned earlier, which you can download from SDK Man and a bunch of other things, the Quarkus CLI has a command that will allow you to create an extension, right? This is very important because the extension structure is very, very important, and it's super easy to get it wrong. So by executing this, Quarkus will create a multi-module project for you, which one area contains the build time code, one contains the runtime code, integration test docs, so a whole bunch of stuff that's set up for you just by running this command, right?
Maybe it's worth showing the actual project structure.
Yeah, and when you run this, right, what happens in the end is you get, oh, sorry, this is the wrong project. What happens when you execute this is you get 4 different, it's kind of hard to see, but you get 4 different modules. You want to, like,
Besides the GitHub and the good idea which are related with the actual code that we are looking at here, the first module is the deployment module. That module contains stuff related to the actual building of the application. And then we have, okay, so the gRPC.
the gRPC is the one we added on.
What we just added, integration test, and then the runtime, which contains things that are tied to the runtime. So, for example, the URL to the actual gRPC service is something that needs to go to the runtime config. The client itself, client implementation, needs to go to the runtime team. Using producers of
No, we'll just
okay.
keep it simple. So yeah, let's start. Basically, like Ioannis said, we need the actual client that we want our consuming applications to use is going to go into the runtime module. So let's start by creating that. So we go here, tracker, client. So this is going to be a CDI bean. So I'm going to say it's a singleton. And remember that it returned what we expected it to return was this mutiny thing that called GPS, right?
Yep.
So there's this method that we want to implement. So now we've got to see, okay, I do have a bunch of like generated gRPC code, but how do I create this? Let's see what the IDE says that we actually need.
So you start from the muting gRPC service and you just say that you need a new muting stub. This stub accepts as an argument a channel, and we'll see a little bit later what the channel actually
Yeah,
is.
so let's see what the channel is, right? So this channel is a gRPC construct, and we need to create it, right? And it basically encapsulates like the communication, like media, right? So let's go ahead and see how we can create that. So let's say channel is manage channel builder. Manage because we are the ones that are going to start it and stop it. But we need to see, okay, this is the method that's really important, right? We need to know what the target of our RPC call is, right? So it's like just like with a REST API, you need to know what you're calling. So you need to know a host, you need to know a port. Same here. So we need a host, we need a port for this, and we'll get to that.
So pretty much you need a URL, right?
Yeah, exactly. We need a URL, and we're also going to say that we're not going to be using secure protocol, so just plain no security. So let's see how we can create this URL, right? So let's say we need a URL input, which is going to be the configuration, right? And we're going to say config get host, config get port. Now, this is CDI, this could be fine. Excellent. Now this is a CDI bean, right? So CDI needs to know how I'm going, what's the value here for my configuration, right?
Yeah, so I think that one possible approach to that would be to wrap the URL inside a config object, or to use a config property for the actual URL.
Exactly.
So we can use configuration properties and then specify the name of the configuration value, which is usually prefixed by the Quarkus prefix, and then we add the name tracker in our case, and finally the URL, which is the name of the parameter.
Now, sorry, let's move this out of the runtime package, because by convention, Quarkus, the convention in Quarkus is that the runtime code that is inside the runtime package is treated as internal code for the extension itself, and it's not supposed to be present, not supposed to be referenced in actual applications. So we'll move it out of there. But now what we do need is we need a way to say that the extension manages this configuration property.
Yeah, so we will create an object that we will call, let's say, tracker config or something. And we'll just say that this is the config root, and the name of the root would be tracker, which is what we added right after the Quarkus.prefix.
So the annotation here is basically a way for our internal, so the extensions have their own API, right? The internals of extensions use their own API. They don't use the regular APIs that applications use. So we need to tell it this configuration is used at runtime, so the URL will be overridable, right? And we need to give it to Javadoc, URL of service providing GPS over gRPC. Now it's important. It's important to provide this Javadoc because the Quarkus tooling automatically generates ASCII doc files when the extension is built in this
And I
doc
think
file.
it's not just the ASCII doc files, but also metadata that can be picked up by ID
IDs,
tuning.
yes, very.
So
very cool.
you can get a completion of those properties from IntelliJ scripts and whatnot.
Very, very important. Yes. Okay, so this is not.
Any plans on bringing support for Emacs? Yeah.
Well, you tell me. You're the only user of it. So this is basically the basic skeleton, right? This is the part that the actual client would need to know, right? So let's see what happens though if we actually try to run, if we actually try to build this project and run like the various sample tests that are created. So the sample tests simply like try to use the client at runtime, right? They don't do anything else. So let's see. Oh, I know what's going on. Yeah, I need to. There's some code left over. So if I install this now, it should fail. Right. So the funny thing is, previously it was passing when I didn't want it to pass. So this should fail with. Great, that's the error message I want to set. I wanted to see. So the generated test, right? So which just do a very basic testing of the extension. They don't do anything. Just make sure that everything. The corpus is bootable.
It's bootable, yeah.
Right. And then we immediately get this excellent error message, right? It says
which ties to the previous talk where we talked about the feedback that Quarkus provides to the users. In this particular case, it detects that we have no idea what the Quarkus tracker URL is, so we throw out
I
an
think we
error.
have a question.
Yes. One more question. Can you repeat again the reason why we need the class that actually maps the URL config property?
You mean this one, right?
Yes. It's the
Yeah.
URL class that actually makes it.
So the tracker config class is actually the way you tell Quarkus the Quarkus extension to integrate with the Quarkus core, right? So this annotation will make Quarkus discover this class at build time and generate a whole bunch of extra stuff, but that allows Quarkus to provide this error message down here, right? So if I had no other way if I just threw a property in somewhere, I wouldn't be able to know that this is problematic, and I wouldn't get the docs or anything else that the extension provides. So an extension, the idea is for it to be self-contained, right? That it provides all the information that including application needs to know in order to make it bootable in production.
I would say that the actual need is to bind this string to this field.
So it's the error message.
So the purpose of this class is to do that.
So
that
documentation
wiring.
plus the error message.
Yes,
Yeah,
exactly.
exactly.
And also the other thing it does here is, the good point that you brought up is that normally configuration is just a string, right? It's nothing else. Here,
It's a URL class.
yeah, the Quarkus automatically maps from a string to a URL class. Right.
I think that before we move forward, don't we need to add a config item on the URL?
We don't specifically, but it's a good idea to do it. But
Okay.
yeah, I don't think we don't really need to, but it's a good idea to have it there. So now let's talk about the developer experience, right?
Exactly. So we try to run the tests of the extension that we actually created, but we see that we get the issues that mentioned earlier. We need to somehow find where the service ran. We need to find how to start the service, how to wire the application with the service, and all that stuff. For that purpose, in order to free developers from those concerns, we are going to create a dev services build item in the extension so that it takes care of those things. In other words, what George is going to show right here is how we are going to automatically get a container started that will provide that service, and how the dev mode will inform the app of the URL that is required in order to consume the service.
So yeah, the idea is that we'll tell Quarkus to start a custom container, right? So Ioannis has already built a gRPC, let's say, server that simply returns the coordinates that we saw earlier. So when you call it, it returns the coordinates as a stream. Now what we want to do is we want to use that as part of an application that includes this extension. So it's super simple. If you use test containers, it's absolutely simple. All you need to do is create your own, let's say, instance, your own extension of the test containers. And what we need to do is like just a couple things. We need to
the first thing that we need is to tell which is the actual Docker image that we are going to use.
Yes.
So we are going to pass the actual,
yeah, this is
image name.
This is the image
and,
that you've created. And what we also need to do is we need to expose the port, right? So we know that you exposed to port, what was it? 9,000. Okay. Let's configure.
I think it's exposed port
With exposed port 9,000. And let's just do this to make our lives easier. Get map port 9,000.
So, to explain what George is currently doing, when the container starts, it will internally bind to port 9,000. However, outside of Docker, we need the port that this port will be mapped to. So, for example, the container, inside the container, we may be using port 9000, but outside of the container, we are using the mapped port. So we need, when we construct the URL that we will pass to the application, to get the mapped port and not the 9000, which is what's used in the container.
Excellent. And this part here is basically the part that Quarkus executes at the. So Quarkus has, like, let's say, an internal wiring framework for extensions where extensions are able to consume data that is produced by other extensions and produce data that other extensions or Quarkus core then consume. And by adding this annotation and returning this piece of information, what we making Quarkus do is that we're saying that when Quarkus knows that it's time to execute all the dev services that it's supposed to, it should run this one, right, which is this container that we're talking about. And let's see what other information we need to pass.
The container ID, once you start the container, you need to provide information on how to terminate the container when you are done. And finally, you need to provide a map that will include all properties that will be passed to the actual application. In this particular case, we are only interested in the URL of the service. So we will create a map on the fly where we are going to pass the host and the mapped port.
Yeah, so remember the property that was missing because, like, there was no way, we didn't know what we were executing against. Well, now is where we actually tell it where it's executing against. It's executing against container get host and container get port. Okay, so this should be it. So let me install this. It's not it. Yeah.
You need to get the to-build item in the end or something like that.
Right, yes. So I need to turn this into the proper data. Excellent. Okay, so now I'm basically building the entire extension, right? So hopefully all the tests will pass, and then that will mean that the extension is ready to be used by the Quarkus application that we already have, right? So once this is finished, I'll pivot over to the extension and see what we have.
Fingers crossed.
It's looking good so far. Okay, so yeah, there's a bunch of tests.
So before we move forward, I'd like to maximize this slide. So,
which one?
This piece of code.
Right.
The generic container bits are provided by the test containers project. It's not something Quarkus specific. And in order to create the actual dev container, the only Quarkus code that we actually need to write is, can we scroll up a little bit?
Yes.
Is this three-liner or something. It's pretty trivial and it can be done very, very fast.
Excellent. So with that in mind, now we have our application, right? Let's go back to our application. We have a question.
Will this extension be included in the final jar reveal?
Yes, exactly. Very, very good point. So in here, so I've already added the name of the extension to the POM of the application, right? So it's Quarkus GPS tracking client. And when we build the application, if I want to build it, right, I'll go package, skip test.
I think that the question implies whether we get an overhead or unneeded burden on the final app jar.
Yes, exactly.
Oh, okay. The burden is only that you have like two extra classes, right? Which are CDI beans.
Yes, it's a small burden, but if we have dependency, then
Yeah, well, that's the point, though, isn't it? I mean, you wouldn't do this if you're just going to do it in a single application, right? If it's just I want to do this application and nothing else, then yeah, there's no point in going through all this
You may
complexity.
still want to do that if you want to leverage dev services and,
Sure.
and stuff like that.
Yeah.
As we all already mentioned in the beginning of this talk, one possible solution would be to directly generate the gRPC related stuff in your application. And if you want to avoid unneeded overhead or stuff like that.
Yeah. So the general idea would be that this would implement some cross-cutting functionality that you need in your company, right? So for some reason your applications, like 5-year applications, need this GPS tracker thing for some weird reason, right? So you would add it there, and then the overhead is trivial. You absolutely, I mean, the runtime overhead. You don't need to think about this at all because, again, it's just CDI code that Quarkus already processes at build time. Quarkus also has the fast jar, as we call it, where it knows where each class, which jar contains each class, so it doesn't have to open every single jar until it finds the fast needs, like all of the frameworks do. So the overhead is like very, very small, totally insignificant. So. Yeah, and when I built the application, if I really wanted to see where the thing ended up, I would go to the lib directory, the main, and I would find my extension in here. Right. So now we're just going to show that if I start the application, and I have not configured the tracker URL anywhere, right? All I'm going to do is start the application in dev mode. And hopefully now, see it's starting the container, the dev services container that we defined in our extension. Quinoa did a bunch of Node.js things to install the UI and things like that. So now if I refresh, I should actually, yeah. So we see the vehicle progressing on the map, obtaining coordinates dynamically from a Docker container that we can verify is running by the Docker. Yes.
Can we go and show the resource and how the final code actually looks like?
Absolutely. So the final code is this, right? All you have is a resource. You get your tracker client injected into it with CDI. Because we define it as CDI bean, and then you return basically a multi of strings, right?
Exactly.
Questions?
Just realizing we're here 4 hours and we haven't shown a native build.
Yeah, that's a good point.
Not a single one.
That's a good point. Very good point, yeah.
So the next step would be to build the whole thing as a single binary, native binary.
Yeah. So I'm gonna have to run Docker run and
Since we are going to build and run the application on native mode and thus in production mode, we won't be getting the benefits of their services, all that stuff. So for that purpose, we will need to actually run the service ourselves. And this is why George started the GPS tracking service using Docker, right?
yes, but the problem is that it's also downloading the native. I don't have GraalVM 22.2
Yeah,
on this machine.
Yeah, it will take a while.
Yeah, I'm downloading it with 4G. So yeah, so basically what Quarkus is doing here, because I don't have GraalVM 22.2 on this laptop, because this laptop was just sent to me. What Quarkus is doing then, it knows that okay, if I don't have GraalVM installed locally, then I'll use a container to build it. So I don't need to install GraalVM. Quarkus will download a container that can build it for me, and will then progress to invoke GraalVM, right? But this looks like it needs 260 megabyte, and yeah.
How long do we have at our disposal?
Well, I think we're already over time.
We are?
Yeah.
Okay, the great thing with this approach is that we will end up having a single binary, a single native binary, that will also embed the React app, right?
Yes.
Which is
Yes.
which is pretty amazing.
Yeah, but I don't know. It's still at 50 megabyte, and you download 260.
Okay, while it's still downloading, do we have other questions you might want to ask?
Well, you say native. Assume that it's a functionality of GraalVM. For us who are not familiar with GraalVM, how native? And I saw that maybe the command you put, you just activated the option native. What architecture?
You want to take this one?
Yeah, sure. So the GraalVM, let's say that the general idea of GraalVM native image is that it builds a native binary for the OS and the architecture that the application that it's running on, right?
The host for you.
Yeah, the host. So there's no, as of today, there's no cross compilation to like ARM or anything else. So I'm running on Linux and x86. So that's what it's going to produce, right? An ELF binary for x86 64. Does that answer your question?
So, can I have a follow-up? So if you want your application to support a different architecture than the one on your machine, you need a different machine.
Yes, exactly. Currently, yes, that is the case, yes.
We mentioned in the previous talk when we discussed about roadmap and stuff like that ARM support is coming, but
Yeah, I don't know what the... Well, ARM support is already there, but you need an actual ARM machine to build it, so I don't know when cross-compilation will be. So I don't think this is going to finish, actually, because it's at 106 and 260, so yeah, I don't think this... I don't think this is going to work.
okay, no worries. Do you want to, while taking more questions, also show the end result, which is far more interesting than seeing the progress bar?
Well, the end result, we already saw it, right? Oh.
Okay, do we have other questions? So it seems that there are no more questions. Thanks again for being here with us through 4 sessions of many of you. Again, it means a lot, and I hope that you enjoyed what we put together.
And enjoy the rest of the conference. Thank you.